let's understand a synthesis in which we use the property of sp hybridization for increasing carbon chain number. For this purpose, the molecule that we choose is ethine. It has C triple bond C, so this carbon has sp hybridization. Since it has sp hybridization, so this hydrogen is highly acidic. What do you mean by highly acidic? Highly acidic means this can come out as this CH bond can be cleaved as H plus and C minus. And along with that, we have taken lithamide. Now, what does lithamide? Lithium is lithamide. We also call it as lithium amide. Now, this lithamide, lithium we know is highly electropositive, and nitrogen NH2 nitrogen has lone pair, so it does a nucleophilic attack on this hydrogen. Hydrogen gives its shared bond pair to carbon. As a result of that, what happens is this forms HC triple bond C, C minus. Absolutely unstable. This forms this, and now this is negative. Lithium, highly electropositive, so that combines with this to form ethinyl lithium. That is, this is your this part, and lithium is your this part. So lithium combines here to give this molecule, and NH2 takes the hydrogen, rather I would say proton, takes the proton to form ammonia. Alright, I repeat it again. The NH2 does a nucleophilic attack on H, gives its electron pair to carbon, forms carbanion. Carbanion combines with lithium, which is highly electropositive, to give you this compound. So this is the same thing over here with Li plus, and NH2, since it took this, that's what I've written in short over here, NH2 H plus forms ammonia. Ammonia is very stable. Now these type of compounds are known as ylates. These type of compounds are known as ylates. Alright. Furthermore, then what happens is, now this compound which is there, this if we reacted with any alkyl halide, now here what we have chosen is ethyl chloride. When we react with this ethyl chloride, alkali metals have got strong affinity for halogens. So lithium and Cl combines to form lithium chloride. Alright, forms lithium chloride, which is the byproduct. And this and this. Now here addition occurs. Alright, the coupling occurs over here. Now, so what happens is, this part which is there from CH2 it attaches here. So see, this part is this part, and this from here CH2 attached CH3. So what we end up is with but 1-ine. Alright, triple bond. Now one thing I must clarify over here, that is very difficult to synthesize a molecule with triple bond intact. Alright, here owing to its property of sp hybridization, this synthesis is possible. This is lithamide, this is lithium, and this is amide part, lithamide, and this is acetylene. Now in case of acetylene, now triple bond we see carbon carbon, triple bond CH CH. So this, both the protons are highly acidic. So this can cleave as H plus, and this can cleave as H plus, and this can attack over here. Nitrogen can attack over here, take this, form ammonia. This nitrogen can attack here on this hydrogen and form ammonia, and this would form ionic bond with this. This would form ammonia and fly away. So this is the product that we are interested in. This would form ethynyl lithium. Alright, so the product that we get is ammonia byproduct, and along with that the product that we get is ethynyl lithium. Now in step 2 we take ethynyl lithium treated with ethyl chloride. Now when we treat with ethyl chloride, what happens is lithium combines with chloride to form lithium chloride, which is the byproduct, whereas this combines with this methane, ethane, propane, butane. But in one position we have got triple bond, so what we end up is with but 1 ine. We used acetylene. Now in acetylene we had sp hybridization over here and sp hybridization over here. So these both the hydrogens were highly acidic. Alright, but we saw reaction just with one hydrogen. Would it not occur here? Yes, it would be occurring here. So let's understand now. Now see, we are taking acetylene, reacting it with lithamide. So what happens is this lone pair of nitrogen does a nucleophilic attack on H, and H loses its shared electron pair to carbon. So this forms ammonia. So I repeat again, does a nucleophilic attack on H, the bond pair which is there is shifted on carbon, rendering carbon carb anion, and this carb anion then does a nucleophilic attack on lithium. So lithium gets attached to carbon this way, and NH2, the amide part, gets converted to ammonia. Same process happens here also. So basically we end up with 2 moles of ammonia and dilithium carbide, dilithium acetylide. As I have already explained that these type of compounds are called as ylides. Alright. Now lithium, just to say something about lithium carbide or dilithium acetylide, it's an intermediate produced in radiocarbon dating procedure. Alright. Also it's used in mass spectroscopy, which is an instrument used in analytical chemistry. Now let's go to step 2. In step 2 we are using ethyl chloride, 2 moles of ethyl chloride, and our lithium carbide. Now this Cl reacts with lithium. This Cl again reacts with lithium to give 2 lithium chloride, LiCl. We know lithium is monovalent, so Cl, LiCl. So the product that we end up is hex 3 ine. How? This ethyl gets condensed with this carbon. This ethyl gets condensed with this carbon. So what we find is C2H5, C2H5, 2 ethyl groups attached to 2 carbon. So now this is a 6 carbon compound, so hex, and in third position we have triple bond, so it is 3 ine. So the molecule is hex 3 ine. Let's understand the reaction with 3-dimensional molecular modeling. Alright, now this we know is lithamide, NHNH, and lithium, NHNH and lithium. So lithamide, and this obviously is acetylene, triple bond, C triple bond, and H. Alright, so when it reacts, what happens? Now already I told you that lone pair of nitrogen from here attacks this proton and forms ammonia, and then carbon does a nucleophilic attack on lithium. Similarly here also, lone pair of nitrogen does a nucleophilic attack on H, Now why H? Because owing to sp hybridization, H is highly acidic. So lone pair of nitrogen does nucleophilic attack on H, forms ammonia, and this bond shifts over carbon, and this does nucleophilic attack on lithium. So let's understand what are the products. So we end up with lithium carbide and two ammonia molecules. Now let's proceed to next step. This ethyl gets condensed with this carbon. This ethyl gets condensed with this carbon. So what we find is C2H5, C2H5, two ethyl groups attached to two carbon. So now this is a 6 carbon compound, so hex, and in third position we have triple bond, so it is 3-ine. So the molecule is hex 3-ine. In step 2, we have taken 2 moles of ethyl chloride, CH3, CH2, Cl, CH3, CH2, Cl with lithium carbide. Now we know that highly electropositive, highly electronegative would form lithium chloride, and this would get attached over here. Here also lithium, highly electropositive, highly electronegative, would form lithium chloride. So it would form 2 moles of lithium chloride and 1 mole of hex 3-ine. Let's see how it appears. Conventional molecular model. So we have 2 moles of lithium chloride, 2 moles of lithium chloride. Let's take it out as it's the byproduct. And this is our molecule, CH3, CH2, C, triple bond C, again CH2 and CH3. In first, second, third carbon, we have got a triple bond and it is a 6 carbon molecule. So hex and 1, 2, 3 ine. Hex 3 ine is the molecule that we end up with.